So Itay Izhak from Cognitive Bias will give the next talk.
Okay, so hi everyone, I'm Itay, and this work is called Instructed Bias. And in this work we show that language models show cognitive bias which is similar to humans. This is a joint work together with my colleague and advisors, Neil Rosenfeld, Gabriel Stanowski, and Yonatan Belnikov from the Technion and Hebrew University. It will be presented in the upcoming ACL. Okay, so it's going to be a bit interactive. I'm going to tell you about a situation, and you will try to make a choice that you would actually do if you were in this situation in real life. Okay, so the situation is this. You need to buy a new phone, so you go to a phone store. At the phone store, you have a couple of options. Each option have two main properties. One is price, and the second is quality. You need to make a choice based on these properties. I'm going to show you now the options that you see at the stores. Just try to make the most natural choice that you would do. No wrong answers. I'm not going to test you, I swear. So these are the phones that you can see. You have phone brand 1, which is priced at $200 and have a quality rating of 40. And you have phone brand 2, which is $500 and a quality rating of 60. It's between 0 to 100. Okay? It's imagine it's your own internal quality measure. So take 5 to 6 seconds, just trying to make a decision. What would you choose? Okay. So just out of curiosity, who here chose brand 1 by show of hands? Okay, brand 1, cool. And again, by a show of hands, who chose brand 2? Okay, cool. So about 40% I think towards brand 2. Okay, cool. So imagine if there was another option, another phone brand, and try to make a decision if you would change your original decision based on the additional option that you can see. And the third option is this, phone brand 3, priced at $650 with a quality rating of 60. Anyone here think he or she will change their decision? Okay, so most of you wouldn't. And basically, logically speaking, it's kind of weird to change your decision based on this additional option. Why? Because brand 3 is basically worse when you compare it directly to brand 2, right? It's more expensive and has the same quality measure. So if you chose brand 2, you have no reason to change. And if you chose brand 1, you have, again, not much reason to change because you prefer the cheaper and more just the cheaper option. Okay, so weirdly as it sounds, psychologists found that humans basically do a lot of decision changing based on the changing of the settings. Meaning, when they are presented with two choices, psychologists call this the control setting, and people make some arbitrary choice like you did here about 60-40. But when people are shown the third option, it's called the enrichment setting, and people tend to change their choice. So when psychologists basically tested it, they showed that if you want more people to choose brand 2, you need to add a brand 3, and this will make people choose more brand 2. So why am I talking to you about this? Right, we're in AI week and we're talking about models. As most of you probably guessed it, like I said earlier, we wanted to show if this bias, which called the decoy effect, and it's a well-studied cognitive bias shown again and again and again, we wondered if we ask language models to make similar decisions, will they make the same cognitive bias mistakes that humans tend to do? So this is our research question. if a model was in the same situation in the control and the treatment, will it change its decision? So our motivation for that is pretty simple. We're in the ChatGPT era, right? Models are pretty good and they are very human-like, but as we all know, they also make mistakes and have social biases. And we wondered if they can learn social biases from people, could they also learn if they can learn social biases from people and from data, could they also learn cognitive bias? So we had to choose which biases are we going to explore, because there are over 100 cognitive biases and not all of them are fitting for the LM settings, and some are fitting but are not that interesting. So we ended up, after reading a lot, we chose 3 biases that we thought will be the most interesting. The first one is the one we saw earlier with the phones, the decoy effect, which relates to decision making. And the second is called the certainty effect, which relates to risk calculation. And the third one is the belief bias, which relates to logical reasoning. All 3 are biases that relates to the way we interact and use language models in real day-to-day life. Okay, so we have our biases. Now we need to set up our experiment. And the first thing we need is data. But because this data is not naturally found easily, we had to generate our data. So the first stage was a lot of hard work and trying to read cognitive theory and write examples that would fit the cognitive theory and both be fit into the LM settings. So that was the first step. We did a lot of writing. And the second step was we needed to make sure that our data will be robust to all kinds of sensitivity that we know that language models have, like prompt sensitivity and permutation sensitivity. Okay, so the third stage of that, we needed to make sure that we know how to evaluate the biases in this model. For that, we defined something that we call the bias score. So the bias score is designed to answer the question, how much bias a model displays. So remember the example from before with the phones? We had brand 2, right? Brand 2 is what psychologists call the target option. It means it's the options that people tend to choose more in the treatment settings. So we want to measure, we have our target option, and we want to measure how much people or how many choices are changed in the treatment setting compared to the control setting. And the difference between the choices will basically tell us how much the model is biased. So the bias score is basically a measure that shows how much the model is biased. The higher the bias score, the more biased the model is. Okay, for the last thing, we needed to test it on models, and we chose models from familiar families, OpenAI, Mistral, and Google's T5. We chose all kinds of different models from these families, and we specifically made sure we have 3 types of models. We have large pre-trained models, we have their instruction-tuned versions, and their RLHF-tuned version. This will come handy in 2 sec, put it in the back of your mind. Okay, so the results, by now you probably all guessed it. I wouldn't come here and talk to you about the cognitive biases if models didn't have them. So yes, the result is language models do have cognitive biases, and cognitive biases which relate to decision making, reasoning, and risk calculation, all applications that have real impact in real life usage of language models. And this is very cool and exciting. And I want to show you a specific part of the results, which I think many of you will find specifically interesting. So remember 2 seconds ago when I told you we had a variety of models. We had pre-trained models and their instruction-tuned version and RLHF-tuned version. These fine-tuned version are the version that usually are applicable in real life when you use ChatGPT or other models. They're usually fine-tuned with this method, and they're considered to be state-of-the-art and the better models. Okay, so we're going to look at specific examples that are easy to see. We're going to look at the results of the bias scores of GPT-3, the pre-trained version, its instruction-tuned version, and its RLHF-tuned version. So we have here in our, on the x-axis the results for the pre-trained in blue, the instruction tune in orange, and the RLHF in red. The y-axis is the bias score. The higher the score, the more biased the model is. So for GPT-3, I don't know if you can see that, there's a little line in the bar plot for GPT-3, which means it has cognitive bias, but it's not that high. I mean, you can see that, but it won't throw you out your feet because it's so biased. But when we are looking at the instruction tune version, the bias is much more significant. We took a pre-trained model, did a little instruction tuning, and we got a model that is much more biased in the same way that humans are. And when we take the same model and train it with RLHF, we get that the bias score is skyrocketing, meaning the better the model is and the more is it aligned with human values and needs, the more biased it is. And if you take one thing from this talk, I would say it would be this one, because the best models are also the models that are more biased. And we made sure it's not specific to OpenAI. We tested that. This phenomena is across the board. When different companies train different models, we still get the same trend. Models that are better show more bias. And so basically, I want to leave you with this question. We saw this phenomena and we asked, what does that mean? And I'm asking you this, and try to think about it when you use for your own language models or for your companies or whatever you do. What does that mean when I'm using a model which is really good and is considered state of the art, but it might hide different biases? So basically, instruction tuning increases biases almost whatever you do. The second thing is standard RLHF just seem to make it worse. And this is relevant for open and closed models, so it's everyone's problem. In my opinion, what's next is first bias awareness. That's one of the reasons I'm here. If we use models and we don't know that they are biased, we might have very bad implications that we cannot see directly, because unlike social biases, which are kind of easy to see most of the time, these kind of biases are hard to detect. Second is instruction tuning and RLHF may not be enough as alignment method to make the best models. And for the future, we're working right now on trying to understand how these biases are exactly learned and can we possibly mitigate them. And that's all I got for you for today. Beware of hidden biases in your models. They are there even if you can't see them. Thank you so much. I'm here for questions. Yeah. Hi.
You showed the empirical data, but you didn't find the mechanisms. Like a slight tuning, fine tuning. But apply like without the kind of thought of the methods. How
Yeah.
does it change this?
Yeah, so that's a good question. The question is, did we use a chain of thought? Did we see if we can mitigate these biases by getting the model to think more? So using chain of thoughts and all kinds of different methods changes the trends. They can be sometimes be lowered. We're also trying to get the models to understand there can be biases and then ask them. It mitigates them to some extent, but not entirely. In almost every scenario we checked, models were still biased. But that's a good question. Thank you.
Thank you. We won't take another question.
Okay, thank you so much.
Thank you very much.